Hello again, my name is Marcelo, and today I'm going to be doing Project Euler Problem number 7. This one, no mystery about it, just asks you to find the 10,001st prime, and as an example, it tells you that the 6 prime is 13, so you can use that as a test case. So I'm going to be creating a simple file in Python here, but today I'm going to be doing most of my work in a separate class. If you watched my video solving problem number 3, I created a Newton's file with a class for primes. So what I'm going to do is I'm going to import that class here, and what we're going to do is just call primes.first for the 6 values, and we are just going to list the very last one, and this should be 13. And we are going to do most of the work here in the Euros file. So here we're going to create a function called first, which is going to receive a number n and is going to return a list of primes of the n primes. So if that number is smaller than or equal to 0, then it should return an empty list. Otherwise, we can start with a list with the number 2, which is always going to be there as the first prime, and then we can begin counting primes from 3 onwards. And then what we do is we just check while the length of this list is smaller than n, we continue finding primes. So we continue to increase to 3 the number by 2, and we can check if the current number is co-prime to the current list of primes. So co-prime, it means that it has no common factors. So we just do is co-prime number to the list of primes, and then if it is, we append it to that list, and at the end we return this list. So here for the list for the method is co-prime. Since I'm doing all static methods here, I want to do reutilize the class name here, and then we just retrieve the number n and the list of primes, and we have to return true or false. So the idea is that we can call an all method here, which we used in the previous one of the previous exercises. And here we just need to check that all elements are truthy in this list. So what I can do is we can map from, well, with a lambda function that all elements when divided by n yield the remainder that is not 0, and we pass the list of primes, and I think this should be enough. So if we were to run this here, we get 13, so it's correct. Before we actually run for the main value, we can improve this a little bit by switching here. So instead of primes, we don't need to check every single prime, we just need to check up to the square root. So we can import from a separate lib here in Python. From meter tools, we can import a lib called takewhile, and this will give us a string which will lazily only take the numbers that we want. So for takewhile, we would pass a lambda function here, which is kind of gonna work the same way. So we pass primes, and for each prime we drop if prime is smaller than the square root of n. So I guess, yeah, we already have square root here. Let's just check if this is working for 13. Oh, we made a little typo here. Sorry about that. Let's try it again. We're getting 11 now, so maybe we should try this with an upper bound. Nice. So now to fix this, all we need really is to change this to 10,000 and first, and this should get us our response. So a little bit slow there. We can improve this with some memorization, some dynamic programming, but for now I think it's good enough. Yeah. So if you like this video, like and subscribe. Give a comment if you want to see any other kind of content in this channel. I'd love to do any other kinds of problems as well. But for now, that's all. Thanks for watching.